Good morning. Welcome to Swapna physics classes. Good morning, Madhu. Thank you for joining my live. Thank you so much. I just want to check my audio and video quality. Give me a minute. Thank you everyone for joining my live. Thank you so much. Please click on the like button for encouraging me. Please click on the like button. And who didn't subscribe to my channel till now, please subscribe to my channel. And coming to our class, in our last class we had derived the spectral terms. We had derived the spectral terms for different L values. And if we have the L value L1 and L2 for two different L values, definitely we will be having two different spin values, spin angular momentum values. Okay, S1 and S2. Here I had taken the L1 and L2 as L only. Okay, yes. So therefore the J value will be L plus or minus 1 by 2. We had discussed about this topic in our last class, and by substituting the J value in our by substituting the J value in this equation, J values in this equation, we had find out that two different term values. Okay, that is for delta T1 T prime and delta T double prime, delta T prime and delta T double prime. Okay, this change in energy is due to spin orbit interaction. Okay, due to spin orbit interaction we are having two different term values, and I will continue this lecture. That is, if you find out the difference between these two term values, that is delta T is equal to delta T double prime minus delta T prime. These are term values. Delta T represents the term values. Okay, and I'm taking R infinity. I'm taking common here, R infinity alpha square z power 4 by 2n cube. I will take this common. Okay, R infinity alpha square z power 4 by 2n cube into L plus 1 by 2 into L plus 1. I am just taking the common, and now I am just subtracting this delta T double prime. Okay, I am just subtracting delta T prime from delta T double prime. Therefore here we will have L plus 1 minus plus in L. Okay, therefore here we have L plus 1 plus L, and from here this R infinity, here you just write infinity in base and check this. R infinity is the Rydberg constant, alpha square is a fine spectrum constant, z power 4 atomic number by 2n cube into L plus 1 by 2. I am just rewriting this equation. It is 2L plus 1 into L plus 1, okay, divided by 2. 2 cancelled, and here we have 2L plus 1. L plus 1 is L plus 1 plus L is 2L plus 1. Therefore I am rewriting this equation, and you just observe here 2L plus 1 get cancelled. Therefore we left with R infinity alpha square z power 4 by n cube into L plus 1. This is a very important equation. Very important equation. See, from this equation you can draw a conclusion that this term value is directly proportional to z power 4, that is atomic number, and inversely proportional to the orbital angular momentum, and also inversely proportional to the principal quantum number n cube. So from here you can say that this term value increases as atomic number increases. This term value increases as atomic number increases, and this term value decreases for larger L values. That means as L value increases, term value decreases, and this term value also decreases as N value increases. Okay, you just keep these points in a bracket. These are very important points. Okay, and from here, if you substitute the R infinity, which is 1.097 into 10 power 7 per meter, okay, which is nothing but a Ripper constant, and alpha value, alpha is 1 by 137, 1 by 137, which is a fine spectrum constant. Okay, this is fine spectrum constant. Therefore, you will be having delta T as 584 into z power 4 by n cube into L into L plus 1, L into L plus 1 per meter. If you write in centimeters, this will be 5.84, right? 10 power 1 meter is equal to 100 centimeters, right? So this will be 5.84 into z power 4 by n cube into L plus 1. This is in centimeters per centimeters. So finally the term value equation will be 5.84 into z power 4 n cube, z power 4 by n cube L into L plus 1 per centimeter. It's a very important value. From here you will be having a question for your JL, DL as well as in your NET and GATE examinations. Okay, remember this value. We will solve problems using these equations. Okay, write a question. The doublet splitting. Write a question. The doublet splitting of the first excited state of 2p3 by 2 to 2p3 by 2. N value is 2 and multiplicity is 2, p3 by 2. Okay, 2p1 by 2. So here the electron transmission is taking place from p3 by 2 to p1 by 2 state of helium plus is 5.84 per centimeters. So here in our question, here splitting is taking place whenever the electron transmission taking place from p3 by 2 to p1 by 2. Okay, and the value, this is the term value for helium plus atom is 5.84 per centimeter. Now calculate the corresponding spectrum, for hydrogen atom. In our question we have the term value for helium plus atom and asked us to find out the term value for hydrogen atom. As we know that this term value is directly proportional to z power 4. For helium atom, z value is equal to helium plus atom. It is a ion. Okay, therefore z value is 2. and for hydrogen atom Z value is equal to 1, as we have only one electron in hydrogen atom. Therefore you can write the term value for helium plus atom to the term value for hydrogen atom is equal to 2 power 4, right? 2 power 4 by 1 power 4. Okay, and we need the term value of hydrogen atom. Therefore I am taking the term value of hydrogen atom will be equal to 1 by 16. 2 power 4 is 16 into term value of helium atom, it will be 5.84 per centimeter. It is 5.84 per centimeter. If you solve this, you will have the term value of hydrogen atom, which is equal to 0.305 per centimeter. You just solve this equation. Solve this equation. Okay. And one more question. Take one more question. Write the question. The doublet splitting of the doublet splitting of the first excited state. The first excited state 2p3 by 2 to 2p1 by 2. Okay, the electron transmission is taking place from p3 by 2 to p1 by 2 of hydrogen atom, and its value is 0.365 per centimeter. Okay, now calculate the corresponding spectrum for lithium plus ion, and it is your homework. You have to solve this. Okay, you have to solve this question, and let's go for next topic. Let's go for next topic. Quantum relativistic correction. Our next topic is quantum relativistic correction. Keep a heading quantum relativistic. Please click on like button, and who didn't subscribe to my channel till now, subscribe to my channel. Quantum mechanic relativistic correction. In our previous lecture we had corrected the energy equation as there is a disturbance in the energy, there is a change in energy because of spin orbit interaction, right? And here we are going to consider the quantum relativistic correction. In case of quantum effect, if we consider the motion of nucleus and electron, okay, the mass is reduced. If we consider the motion, that means the electron and nucleus are in motion, they are not in rest position, therefore their mass is reduced. We had discussed this in our previous classes only, and I am considering in our class in relativistic correction, I am considering the electron is at rest position. Okay, and the mass of the electron is m0. m0 is nothing but rest mass of electron, and I am correcting the energy equation. That means for the energy equation for electron which is in motion will be different from the energy equation for the electron which is at rest position. Okay, in this lecture I am going to consider the mass is at rest position. Because of this rest mass, there is a change in the mass of this electron. If I consider the electron is at rest position, therefore there will be a change in this mass of the electron, and I am considering the Hamiltonian equation which is equal to kinetic energy plus potential energy. Okay, where this kinetic energy is the relativistic kinetic energy, and it can be written as p square c square plus m naught square c power 4 all power 1 by 2 plus V. V is the potential energy. This is the relativistic kinetic energy. Okay, this is a relativistic kinetic energy. Okay, and here I am not going to solve this equation. I am not going to solve this equation. Here my intention is to clear you that there is a change in energy because of the rest mass of the electron. See, the energy will be different when the electron is in motion from the electron which is in rest position. Both the energies will be different. I just want to make you clear this. Okay, and because of this relativistic correction, we have a term shift here. Relativistic term shift. Relativistic term shift. Which is equals to delta T, which is a relativistic because of relativistic correction. This will be equal to minus delta ER by HC. Okay, the term shift general formula is delta E by H into C. Okay, energy by H into C. Okay, here I am taking the relativistic correction, and this will be equal to R infinity alpha square Z power 4 by N cube into 1 by L plus 1 by 2 minus 3 by 4. And I am not going to derive this equation. I am not going to derive this equation. Okay. The derivation of this equation here is not so important. So that I am not deriving this equation. Now substitute the R infinity and alpha values which are constants. Okay, then this term shift due to relativistic correction will be equal to 5.84 times Z power 4 by N cube into 1 by L plus 1 by 2 minus 3 by 4a. Minus 3 by 4a. This is a relativistic correction. Okay, here the energy, there will be a change in energy due to spin orbit interaction as well as relativistic correction. In this relativistic correction, we had considered the masses at rest position. Okay, and we had two different term shift values. One is due to spin orbit interaction and the other is due to relativistic motion. Relativistic motion. These are the two different term shift values. Okay, and coming to the selection rules of fine structure spectrum. See, before that I want to explain you one more point, that is coming to the term shift values here. Yeah, just a minute. Yes, here this one. See, here we have two different values. That means the p orbit. If I consider the p orbit, the value of p orbit, the L value of p orbit is equal to 1. Okay, initially this will be the orbit. That means without any fine splitting of the spectrum, this is the p orbit energy level, and because of the spin orbit interaction, this L is split into two more energy levels. This energy level is split into two energy levels, and one is shifted in upward direction and the other is shifted towards downward direction, and the distance will be L, and here this will be L plus 1. Okay, for L equals 1 we are having two different J values here. Okay, that means here for p orbit, this is split into two more energy levels, Here d orbit is split into two energy levels, that is single orbit is split into double orbits which are having two different J values for a given L value. Okay, yes, and here the electron transmission takes place from these two energy levels to these two energy levels. Initially the electron transmission takes place from single orbit to one more single orbit, but because of the spin orbit interaction, here the transition, number of transition of electron increases. Here only one transition takes place. Here we have 4 different transitions. And what are the selection rules? That means the conditions we are considering for the electron transition. The selection rules are nothing but these are the conditions we have to follow for electron transition from one orbit to the another orbit, or one energy level to the another energy level. Good morning, Shiva. Good morning, Ashok. Thank you for joining my live. Thank you so much. Please click on the like button. Please click on the like button. So here the number of transitions from one orbit to another orbit increases due to spin orbit interaction. So coming to the selection rules, that means the conditions, these are nothing but the conditions. Okay, selection rules for electron transmission under LS interaction, spin orbit interaction. If we have a single electron, for a single electron and multi electrons, if we have more than one electrons, okay, then what will be the selection rules? Let's see. It's a very important one. Okay, very important one. The selection rules will be for single electron, delta equals to plus or minus 1. Good morning, Shivaraj. Thank you so much for joining my live. And delta J value will be 0, plus or minus 1. And for multiple electrons, delta L value is 0, plus or minus 1, and delta J is 0, plus or minus 1. Okay, these are the selection rules. And here, in both the cases, the electron transmission from 0 orbit to 0 orbit, that is for J equals to 0 to Z equals to 0. The electron transmission from J equals to 0 to J equals to 0 is forbidden. This is forbidden. It is not allowed. Okay. The electron transmission from J equals to 0 orbit to J equals to 0 orbit is forbidden. Okay. And let's see one example. As we know that we have different number of series, that is principal series. One is principal series. That means the transition takes place from P orbit to S orbit. And fundamental series and diffuse series. Diffuse series D to P orbit. Fundamental F to D orbit. Okay, these are the different series. That means the electron transmission, the possibility of electron transmission takes place in these orbits. So good morning everyone. Please click on the like button, like icon. Okay, I'm considering one example, that is principal series. Here I'm considering the P orbit whose value L value is equal to 1. For L equals to 1, we are having two different J values, right? J equals to 1 plus 1 by 2 and 1 minus 1 by 2, where 1 by 2 is a spin angular momentum, right? Where 1 by 2 is the spin value. Therefore here we are having 1 by 2, 3 by 2, 3 by 2. These are the J values. Okay, and I'm taking the S orbit. For S orbit, L value is equal to 0. Therefore we will have only one energy level for S orbit. Now consider the electron transmission. The electron transmission, before that here write the J value. The electron transition is taking place from this P1 by 2 orbit, to S1 by 2 orbit, and P3 by 2 orbit to S1 by 2 orbit. Okay, let's check the selection rules. you have to follow these rules for the electron transmission. Initially check with delta L and then after delta J. So here delta L is equal to this is the final state, this is initial state. Okay, final state minus initial state will be equal to 0 minus 1 will be equal to minus 1. And coming to delta J, final state is this is 1, this is 2. One line, first line and second line. I'm calculating these values for first line, first spectral line, and delta J is 1 by 2 minus 1 by 2 is 0. And for second spectral line, delta L value is equal to 0 minus 1. 0 minus 1 equals to minus 1, and delta J value is 1 by 2. 1 by 2 minus 3 by 2. 1 by 2 minus 3 by 2 is minus 1. So here delta L value is minus 1, delta J is 0, delta L minus 1, delta J is minus 1. So both these transitions are possible. Both the transitions are possible. And coming to the diffuse series. Coming to the diffuse series, that means the electron transition takes place from d orbit to p orbit. And one more, I will give you one more example. Diffuse series, the electron transmission takes place from d to p orbit. D to p orbit. Here I am taking the d orbital, and the L value will be S equals to 0, P equals to 1, D orbit it will be 2. L value is 2, and it will also split into two orbitals, two energy levels. Okay, and J value is L plus S and L minus S. Okay, L plus S is 5 by 2, L minus S is 3 by 2. Here we have 5 by 2, 3 by 2. See, always take the higher J value for upper orbit and lower J value for lower orbit, and write the splitting of orbital for p orbit. L value is equal to 1. Here we have 1 by 2. Here we have 3 by 2. Now consider the transitions, electron transitions. From here to here, electron transition takes place from here to here and from here to here. This is first line, this is second line. Okay, and for this J 5 by 2, the electron transition takes place from D 5 by 2 to P 1 by 2, and J 5 by 2 to P 3 by 2. This is the third line and this is fourth line. Now check for the selection rules. Okay, if all the transitions obeys the selection rules, then only the transition is possible. If all these lines, any one of these line didn't obey the selection rules, then the transition is not possible. Okay, let's see. I will check the selection rules. For first line, check delta and delta J values. Delta L, see here 1 minus 2. 1 minus 2 is minus 1, and delta J value is 1 by 2 minus 3 by 2. 1 by 2 minus 3 by 2, whose value is minus 1. Yes, and go for second one. Check for second one. Delta L is minus 1, that is 1 minus 2, and delta J value is 3 by 2 minus 3 by 2 is 0. And coming to the third one, delta L is minus 1, delta J is equal to 1 by 2 minus 5 by 2. 1 by 2 minus 5 by 2. Okay, delta indicates the difference. Okay, and this will be equal to minus 4 by 2 is nothing but minus 2. Okay, and check for fourth one. Delta L is equal to minus 1 and delta J value is equal to 3 by 2 minus 5 by 2 is equal to minus 1. And now check for the selection rules. Go for the selection rules. Delta L minus 1, delta J minus 1 is possible. The transition is possible. Why? Because coming to the selection rules are 0 comma plus or minus 1. For delta L, delta J is 0 comma plus or minus 1. Okay, you must the delta L value must be 0 or plus 1 or minus 1. Delta J value must be 0 or plus 1 or minus 1. Okay, and check this. So this transition is also possible, and check this transition. Delta L is minus 1, it's okay. Delta J is minus 2, is it possible? No. Why? Because this transition line, the transition of the electron from J5 by 2 to J1 by 2 is not possible. The electron transition is not possible. That means we are not having this spectral line. Okay, and check this one. Delta L is minus 1, delta J is minus 1. This transition are also possible. Therefore, for diffuse series, we have 3 spectral lines. 3 fine spectral lines. Okay, we have 3 spectral lines, and you just solve for fundamental series. That is transition from F to D. Energy levels. This is your work, and please keep practicing. మీరు ప్రాక్టీస్ చేసే కొద్దీ మీకు మెమొరీ పవర్ ఎక్కువ ఉంటుంది. అంటే దట్ మీన్స్ ఎక్కువ మెమొరైజ్ చేసుకోగలరు. ఎంత ఎక్కువ ప్రాక్టీస్ చేస్తే అంత ఎక్కువ మెమొరైజ్ చేసుకుంటారు. సో జస్ట్ ప్లీజ్ ప్రాక్టీస్ ఆల్వేస్. అండ్ కమింగ్ టు ది ఇంటెన్సిటీ రూల్స్. One more important topic. Intensity rules for fine structure spectrum. Intensity rules for fine structure spectrum. See, out of these 3 lines, this first line, second line, out of this first line, second line and third line, first line, second line and the fourth line, which line is intense one, which transition line is more intense? Okay, let's check this. For this I will give you a trick to find out the intense line. First of all, check for delta J values. If delta L and delta J values are same, if delta L value is equal to delta J value, that means if both are same, then this line is more intense. This spectral line is more intense line. Okay, and next one, check for if both spectral lines are having same delta L and delta J values, then check for higher J value. So before going to check, I will give you one more trick here. You have to follow the trick that if the energy level or the orbit is less than half filled, contains less than half filled electrons, then go for lower J value. Okay, if the energy level is more than half filled, then go for higher J value. Go for higher J value. Okay, that means, see, if a single line contains the same delta L and delta J values, that line is more dense. But if both the lines are containing delta L and delta J same values, then you have to check for the less than half filled electrons, whether the orbitals are less than half filled electrons or more than half filled electrons. How to check this? Let's see. This diffuse series, if you check this one, in this series you can fill up to 6, then here in this orbit it can be filled with 6 electrons. Here it can be filled with 4 electrons. That means I will give you a trick here. In the numerator here we will be having 5. You just add +1 to this. Therefore you can fill 6 electrons here. And here you can fill with 4 electrons here. That means this diffuse series can be filled with 10 electrons, right? As we know that the maximum number of electrons can be filled in diffuse d orbital is 10 electrons. Okay, and if in p orbital, here in this J, that is 3/2 J energy level, it can be filled with 4 electrons, and here it can be filled with 2 electrons. Okay, total 6 electrons. You can fill this p orbital with 6 electrons, and you just check here. If the question is here, you will be, if you this d orbital in your question, if it is mentioned that d orbital is filled with 2 electrons and p orbit is filled with 2 electrons. Okay, and transition is taking place from d to p, right? Here this d orbital is less than half filled, therefore you can go with lower J value. Okay, otherwise here if this d orbit is filled with some 6 electrons, okay, or it might mention that in this orbit, in J 5/2 orbit, the electrons filled are 4 orbits. That means more than half filled. This orbital is filled with more than half filled electrons. Then you can go for higher J value. Okay, if this orbital is filled with 2 electrons, that means less than half filled electrons, then you go for lower J value. Okay, yes, and in this transition, diffuse transition, let's check this. See here, here in first transition, first spectral series, delta L value and delta J value are same. That means the intensity of first line is greater. Okay, and check for this second one, delta L is -1, delta J is 0, and check for third one, it is not possible. Fourth line, -1, -1. See here also you will find the delta L and delta J are same. That means this is also more intense line. I4 is also more intense line. Then how can you say that which line out of this first one and fourth one, which line is more intense? How can you say that? Good morning, Mansa. Thank you for joining my live. By checking that, if the electrons is mentioned in your question, you just check that whether this orbital is less than half filled or greater than half filled. If the question is not mentioned, if the question does not contain the number of electrons, then go for higher J value directly. Okay, so here the higher J value is here it is 3/2, here it is 5/2 J value. Then go for higher J value. That means this line, this fourth line is more intense. This fourth line is more intense than first line, and write the remaining spectral line, that is I2. This is the way to find out the intensity of the spectral lines. Okay, so I4 is more intense than I1. It is more intense than I2. Okay, and coming to Zeeman effect. Coming to our next topic, Zeeman effect. One more important topic. Listen carefully. The splitting of spectral lines What is Zeeman effect? The splitting of spectral lines. Spectral lines when an electron is placed in magnetic field. When an atom is placed in magnetic field. Because of the effect of the magnetic field, the spectral lines are splitted into two or more than energy levels. Sorry, the spectral lines are splitted into two or more lines, more than one line. Okay, the spectral, for example, one single line is splitted into three lines. This is just because of the effect of magnetic field. Whenever the atom is placed in magnetic field, for example, here I have the magnetic field. Okay, the direction of the magnetic field is this one. Okay, and I had placed an atom in this magnetic field. What happened? If you observe perpendicular to the magnetic field, through a telescope, you will find that there is a spectral line. There will be a spectral line which is pi. Okay, this will be perpendicular. The spectral line will be perpendicular to the magnetic field, and you will find two more lines besides this spectral line. These are denoted with sigma. That means a single line splitted into three lines here. Okay, you will observe three lines in transverse wave. This is a transverse wave. In longitudinal wave, you will observe two lines. Here we are not considering the longitudinal wave. Okay, we are considering the transverse wave. Okay, we are considering the transverse wave. Only. Okay, so Zeeman effect is due to singlet. If the multiplicity is equal to 1, which is known as singlet. Okay, that means to be a singlet, the S value must be equal to 0. So Zeeman effect is observed when the S value is equal to 0 and the multiplicity is equal to 1. Remember this point, very important point. Zeeman effect is observed for S equals to 0. And the energy, the change in energy because of the magnetic field will be mu L GL ML mu B into B, and for spin GS MS mu B. This is mu B into B, and for total angular momentum GJ MJ mu B. I'm not deriving these equations. Okay, just copy them directly. Derivation part is not important. Okay, these formulas are important. Okay, and as we know that this GL value is equal to 1, GS value is equal to 2, and GJ is equal to 1 plus J into J plus 1 plus S into S plus 1 minus L into L plus 1 by 2 times of J into J plus 1, which is nothing but Landé G factor. In our last DL examination, there was a question from this Landé G factor. They asked us to find out this Landé G factor. Okay, And coming to this spectral lines, splitting of spectral lines in this Zeeman effect. Because of this Zeeman effect, first of all we will go for the selection rules. Okay, to draw the spectral lines, first of all we have to know the selection rules. Selection rules for Zeeman effect. Selection rules. Selection rules are ML value, delta ML value is equal to 0 comma plus or minus 1. And this Zeeman effect is known as normal Zeeman effect. Normal Zeeman effect. Normal Zeeman effect. This is a normal Zeeman effect. We will be having one more Zeeman effect, that is anomalous Zeeman effect. Okay, in anomalous Zeeman effect, S value will be not equal to 0, and the anomalous Zeeman effect is occurred for doublet and triplet multiplicity. Okay, and coming to the selection rules for normal Zeeman effect. Normal Zeeman effect. Delta ML will be equal to 0 comma plus or minus 1. See, as I said, in the external magnetic field, there will be a angle, some angle between this external magnetic field and J value. Okay, J is nothing but L plus S. Here we will be having yes. See here, this J is this J precision. This is the precision of J about this external magnetic field. And this will be the precision of the spin angular momentum about this J value, about this total angular momentum, and this is the precision of L bar. Okay, in external magnetic field, before we apply this magnetic field, the Z direction will be along Z axis. When we apply this external magnetic field, this J makes an angle with this external magnetic field. It will be theta. Okay, and coming to the spectral series. I'm considering principal series. For principal series, the electron transmission takes place from P to S. Here the number of splittings will be 2L plus 1. The number of splitting of energy levels will be 2L plus 1. Okay, one more important point, remember this. So whenever the electron transition takes place from P to S, okay, initially we will be having, so before drawing the spectral series, you have to find out these 2L values, 2L plus 1 value. For P orbital, 2L plus 1 will be equal to 2 into 1 plus 1 is 3. 2L plus 1 is 3. That means this P orbital is split into 3 energy levels, and S orbit, coming to S orbit, this will be 2 into 0 plus 1. It will be equal to 1. Okay, that means this energy S orbital is not splitted. This S orbital is not splitted. This is the P orbit splitted into 3 energy levels, and here we will consider ML values, not J values. And coming to the ML values for p orbital, it can take values from minus L to plus L. Okay, so here L value for p orbital is equal to 1, therefore ML values will be plus 1, 0, minus 1. Okay, here take plus 1, 0, minus 1. Higher ML value for higher orbit. Okay, and S. For S, ML is equal to ML value is equal to 0. Now consider the transitions. Transition from plus 1 to 0, 0 to 0, minus 1 to 0. Therefore, this is first line, second line, third line. For first spectral line, check this delta ML value. We are going to check the selection rules. Okay, we are going to check this selection rules. Delta ML value. First line, that is 0 minus 1, 0 minus plus 1, 0 minus of plus 1 will be minus 1. So this transition is possible because in selection rules we are having minus 1. Okay, and coming to the second line, delta ML value will be 0 minus 0 is 0. This transition is also possible. And coming to the third line, 0 minus of minus 1, 0 minus of minus 1 will be plus 1. This transition is also possible. Okay, see here, for second line, it is the value of ML is equal to 0, and this value is minus 1, this is plus 1. Delta ML values. See here, this centered line is represented with pi, denoted with pi, and the lines besides this pi is sigma. Okay, and going for diffuse series. Coming for diffuse series. For diffuse series, first of all find out ML values and 2L plus 1 values. Okay, transition from D to P series. Okay, and for D energy level, L value is equal to 2, therefore ML can take values from minus 2 to plus 2, minus 2, minus 1, 0, plus 1, plus 2, and 2L plus 1, that means number of splitting of this d orbital will be equal to 2 into 2 plus 1 equals to 5. That means this d orbital is split into 5 energy levels. And coming to p orbital, L value is equal to 1, and 2L plus 1 value is 3. That means this p orbital is split into 3 levels, and ML value will be minus 1 to plus 1, minus 1, 0, plus 1. Now write the transition of the electron, possible transitions. Okay, and I'm taking 0. This is for D orbital, 1, 2, 3, and we have 2 more lines. Okay, and ML value is plus 2, plus 1, 0, minus 1, minus 2, and for p orbital, 0, plus 1, minus 1. Now check for the transitions, and I'm taking this, if the electron is in minus 2 orbital, I'm drawing the transition lines. Okay, and for minus 1, and for 0, 0 to plus 1, 0 to 0, and 0 to minus 1, and you just draw all these spectral lines, and check for selection rules. Will be equal to 0 comma plus or minus 1. Okay, these transitions only possible, remaining transitions will not be possible. Here I will give you a trick. If the transition takes place from 0 orbit to 0 orbit, the delta ml value is equals to 0. And if the transition takes place from higher ml value to lower ml value, okay, then delta ml is plus 1 positive. If the transition takes place from lower ml value to higher ml value, then it will be negative. And check these possibilities. And draw the possible spectral lines only. This is your work. Find out the possible number of transitions. Okay. Yes. Okay, here I will end our lecture. And who didn't subscribe to my channel, please subscribe to my channel. Good morning, Hari. Thank you for joining my live. And please like my lectures. If you like my lectures, please click on like icon and share with maximum number of people. And if you have any doubt, you write in the comment section. I will explain in the present lecture itself. Otherwise, I will explain in our next lecture. Okay. Thank you.